All right, we should be live now. All right, good afternoon, everybody. Hope you've had a great start to your week so far. I hope you had a great weekend. I know it's Monday. Apologize again for the last minute notice. I wasn't really expecting to do a stream today, but I had some time come up with my daughters going to a music class right now, and dinner good to go. I don't know if you recall last week, but they had their music class, but I had to cut the stream out early to prepare dinner. So dinner's in the crock pot, dinner's good to go, and so we've got time to do a live stream. All right, so today, as the title suggests, we are going to focus in on Dockerizing our API. And Docker is an interesting thing. I read a tweet or a meme sometime that was, I don't remember what it was, but it was along this idea of like, try explaining Docker to somebody from like the 1500s or whatever. And it's interesting because like, it's hard to explain what Docker is if you don't have some underlying knowledge of like what other things are. So before we get into it, I just want to do a quick recap of what we did last time. I'll go ahead and share my screen here. So like we did last time, we built our API, our model serving API. It loads up our RFC pipeline from or RFC standing for Random Forest Classifier pipeline from the pickle file. And then we have two endpoints. We just have a regular health endpoint, and we have this this more robust prediction endpoint. And so just to show you that this all works just fine, I have our terminal here, so I'll go ahead and start up the API on the left side, and then I'll go ahead and do an inference on the right side. So to start it up, I'm going to do the bash start API, so that's our little shell script here. And again, I am, before moving forward, I do have the YouTube live chat window open, so if you have any questions, feel free to drop them down in there, and I would be glad to answer those. All right, so the API has been started, and so I am on the right side. I have here, let me go ahead and move my face out of the way for you. Sorry, I'm a little bit. Is that better? Hopefully that's better. Okay, so you could see that there. So if I go into my test scripts, or curl scripts, I like to keep my things organized appropriately. All right, so let's do a bash local predict, and you can see that it failed out. So I wonder why it failed out. Test JSON is empty. Oh, I wonder if it's because of refactored things. So I can't remember how I refactored these things. So let me go into test curl scripts. And I'm going to guess it's that, yeah, so I just need to make this go up one level. Sorry about that. I'm really bad about refactoring things after the fact, but I really like cleanliness and organization. So, all right, so, oh, duh. All right, so there we go. All right, so now let's try this again. Sorry about that, folks. Bash local predict, and you can see off on the left that we did get a proper invocations with a 200 status, 200 being okay. And then off on the right, we got our survival prediction as expected. All right, so now we are ready to put this into a Docker container. All right, so, oh my gosh, grabbing the wrong things, people. Sorry about that. Let's see if I can grab the right thing this time and move oh my gosh, I'm doing that again. Sorry about that again. All right, my trackpad's being a little bit odd. There we go. All right. Okay, so let's talk about what Docker is. So let's start a little bit basic. So obviously you're familiar with what a computer is. A computer is probably the device you're working on, even if it's a smart or a device that you're watching this video on. Even if could be a laptop, could be a tablet, could be a smartphone. All these are different computational devices. Even this, the watch on my wrist here, Apple Watch, is a computational device. These are hardware devices, but what we can do is we can even though they're running in one operating system, usually we can do what we call partition things into virtual machines. So on a Mac, you might partition your machine to have your standard Mac OS running, and then you can also reboot it to or not even reboot it, but have it run in parallel, something like Windows. So you'd have two operating systems on that. So when we partition things like that, we usually call those virtual machines. And obviously, called a virtual machine because it doesn't have its own like dedicated hardware or anything like that. So what is Docker then? So the way I like to think about Docker, functionally speaking, is that it is a slimmed down version of a virtual machine. So with virtual machines specifically, there are some challenges to doing those things. So like a virtual machine has to have all of its own resources for everything. So like you think about the underlying operating system itself, or the all the coding, or the, what do you call it? I'm just not. Today, I apparently must not have needed to do a live stream because I'm just blanking on everything. But all the dependencies, so like I'm thinking of all the pip libraries and things like that. Whenever it comes to Docker, we use Docker because Docker can do a couple of fancy things that help us to slim down those virtual machines, and then also make things really easy to deploy. So, like for example, like let's say I have Python and I want to use it across a couple different Docker images, and so by the way, an image is basically like the computer, like the version of like this operating system and all of its dependencies that we want to use. So we refer to them as the image, but we build from the image a container. And I think I'm doing a really bad job of explaining all this. But anyway, I mean, like at the end of the day, you don't need to understand how Docker necessarily works on the inside, other than just understanding that it helps with like virtualization of machines a lot better than like actual virtual machines, just because virtual machines do too much sharing of resources and things like that. And also, we use Docker containers in multiple capacities. So we can use them as standalone Docker containers on our local machines. We can use them on an orchestration platform like Kubernetes. And then later on in this series, I'm going to talk about how we're going to use these Docker containers within AWS and their service called AWS SageMaker. All right, so that was my very, very awful explanation of what Docker is. I apologize. So just being a little bit transparent, like 5 minutes before I got on the stream, I was just thinking, I don't know why, but today's stream is going to go bad, and so far not going great. So let's hope things get a little bit better. So I'm going to share my screen again, and I'll go ahead and shut this thing down here, and then I'll go ahead and close out these terminals down here. Okay, so there are a couple different parts to a Docker, what we call a Docker file. So actually, let me go ahead and create a Docker file for us. And so, just one quick refresher. So you might notice on the left navigation here that we have our directories. And I noted last time that I like to put all of my scripts inside of a container directory. That is because you'll see here in a little bit that these scripts are going to get copied into our Docker image and then used appropriately. So when it comes to actually using a Docker image, there are basically 3 different steps, I would say. And you know, I'm simplifying a little bit, but you have a base image that you build on top of, and there are lots of different base images, and we'll talk more about base images here in a bit. Then we need to install all the dependencies that we need to on top of that Docker image appropriately, and then we need to move our files from our directory, our local working directory, into the Docker image. That way, whenever the Docker image starts up, it can make use of those. All right, so the way that we define a Docker image is with something called a Docker file, and I usually like to create my Docker file at the base root of the directory. The syntax is just, or the file name syntax is just Docker file, no extension or anything. So I'll go ahead and add this, so you can see that off on my left navigation here, we have created the Docker file. And like I said, we need to do a couple of things. So we need to instantiate the base image. So like I have said before in other live streams, I like to do my code commenting with annotations, or like consistent verb usage like this, like with the ending of the ing. I need to Google what that is. Today apparently is just not my day for live streaming. I'm just all over the place as far as like where my brain's at. All right, so we need to instantiate the base image, and then we need to install our dependencies, and then we need to moving. Okay, sorry, I'm already confusing myself. Moving the project files from local into Docker image. Okay, so these are the basic things that we need to do. There's a little bit more complexity to this. All right, but Docker image, not Docker file. We'll get into those as we want. So as far as instantiating the base image, so like I said, there are already a ton of base images that already exist out there. You can create a base image from scratch if you want to. I do not advise that, just because that requires you understanding probably a lot more about Docker and operating systems in general than you care to understand. And some of these Docker images they're a little more general. So like you can actually download a Linux Ubuntu image that is just Ubuntu, or a Debian image, or you can get something that's more specific. So like there are Python specific images, or you can get something that's really, really, really specific. It just depends on what you want to do. So actually I'm going to, for the purposes of our live stream, I'm going to use a Python image. We're going to come back at a different point, or I'm going to have to refactor this later point, just because as a machine learning engineer, I am cognizant of security practices, and there are some potential vulnerabilities with some of the Docker images that we've noticed. But for simplicity's sake, we're going to use the base Docker image. So, by the way, if you want to research what sorts of images exist out there, we have something called Docker Hub. So Docker Hub is the primary place where people upload their Docker images for use. You don't have to upload your Docker image to an image library. You can keep it local. You can use something like GitLab to store your Docker images, or on AWS, as we'll see later, we'll use something called the Elastic Container Registry to store our Docker images. But Docker Hub, like I said, is primarily where we start things out at. So you can go in here. I already have a Docker account. You don't need a Docker account to actually download these things. If you do want to upload your own things, then you do need your own Docker account. So you can actually see, oh wow, I can't believe that's been over a year now. A year ago, I did something with MLflow. That was fun. So wow, it's been downloaded. No, that can't be true. It says it's been downloaded over 10,000 times, which would be insane if that was true. Okay, sorry. Rabbit, dog, I don't know. I got distracted. All right, so anyway, let's go back up to Docker here. So like I said, I just wanted to search Python. So we're going to keep things simpler for ourselves. Python, and you can see all the documentation. This is an official image, as you can see here. If you want to do a Docker pull, it shows the commands how to do this here. Oh, and I should have mentioned that I'm sorry, I'm all over the place again still. If you want to make use of Docker, just Google Docker and then like how to download it. There is like a desktop client that you have to download if you're going to use it on your desktop. And then there's like an associated command line interface that goes along with that. And so that's what this off on the right here is showing, is that you can, if you wanted to make use of this image as is, then you can do this Docker pull Python command. Okay, so you can see in here with all of these Docker images, they have like different variants of them. So if you want like a slimmer image or a slim bust or an alpine image, you can do all that. I've never even seen Bullseye before. That's interesting. But I'm not gonna go into detail on what those are. In fact, and I'm just gonna keep things super basic. But you can see here, these are all the different tags. I didn't even know there was a Python 3.10. That's kind of sad on my part. But we are going to make use of Python 3.9. And so we can make use of any of these tags. So I'm curious just what is the standard latest version. I think I'm just going to grab Python 3.9. Well, let me check the tags just to make sure. All right, so it looks like lots of people have been uploading different things. So I wonder when this, okay, so last push 5 days ago. I just wanted to like a simple, I wonder what Python latest is. Okay, let's just stick with Python latest, see if it works. All right, no, I don't want to do that. I'm going to use Python 3.8. All right, so within our image here, we need to define the base image. So you can see Docker pull Python latest. This is the name of the image. So usually with Docker images, you have it defined as this nomenclature here of like the actual image name, and then the tag, the appropriate tag. So in this case, the latest, we could use latest here if we wanted. A lot of images do have a latest variant. I wouldn't advise necessarily using a latest variant just because it could get updated in the future and break your things. You always want to use pinned things, and we'll talk about more about pinning your dependencies here in a bit. But I just want a standard Python 3.8 image, and I wonder, so I'm going to look for 3.8. 3.8.12 slim. All right, so these are all slim, slim, slim. All right, so here's like a standard 3.8.12. So I'm just going to copy this in here, and you don't have to. Whenever you're creating your Docker file, you don't want the Docker pull command. That's just for working within here. So what you want to do is you want to start off things with this from keyword, and then define your base image that we're going to be doing here. All right, so simple enough. Okay, so the next thing that we need to do is install our Python dependencies. So in order to, well, actually, no, I think you need to, well, no, we'll stick with our Python dependencies. So as I was just noting here, so whenever you work with any machine learning library, Python library, anything, you want to make sure that those versions are pinned. Now, what I mean by that is that whenever you go and want to install your dependencies, that you are saying, I want this very specific version. And the reason for why this is super important is because libraries get updated over time for whatever reason, security purposes or whatever, and sometimes the functionality of things break. And so when you think about the pickle files that we've created for our random forest classifier model, or even a random forest classifier pipeline, those things will break if, for example, they're using like an older version of pandas, and then I update, and then it's using a newer version of pandas. So that's why it's super important to pin your versions. All right, so let's talk about how we're going to do that here. So the way we, as you might recall, we do a pip install to install our Python libraries. Let me go back to sharing my screen here. So what I like to do is in this dependencies directory, which is currently empty, I like to create a new file. And we're going to call this requirements.txt. And so this is just a simple text file, but this is going to have all of the Python libraries that we need to support our effort. And they are going to be version pinned. So I am going to say, and I like to separate, because you can use these hashtag commands or # commands for commenting. So I'm going to call this model dependencies. And then I'm going to call this deployment dependencies. So let me make this a little bit bigger for real. Deployment dependencies. All right. Dependencies. And I'm also a stickler for making sure these things are in alphabetical order. So for the things that we need, I know we need category encoders, if you remember this. Category encoders. We definitely need pandas. We need scikit-learn, scikit-learn. What else do we need? Under our deployment dependencies, I know we need fast API. Up here in our model dependencies, we need Cloud Pickle, which for our model serialization. Cloud Pickle. Down here, we need Uvicorn, and that may or may not be it. Okay, so that's just listing out the libraries as a whole. Now, as far as version pinning goes, in order to do that, we just go with each of these respective files, and we do an == sign, and then we will note the version that we want to use. And so if you're not sure what version you're using, and I really should have started this project off talking about virtual environments, but I didn't. So virtual environments, in case you're not familiar, are basically like a way to locally create this environment that matches all the dependencies for a given effort. And so you can create virtual environments for each individual effort, and which is important because each of your individual efforts may have different dependencies or different dependency versions, very similar to what we're doing here with version pinning. And I did not do that for our project, so I apologize for that. But if you want to just look at your what you have installed on your local machine as is, from a pip perspective, you can just do a pip list. And Pip List will show you everything that you need along with the version that is currently installed. Okay, so for example, I need the category encoders and version. So let's scroll on up, look for that, category encoders. Where are you at? 2.2.2. All right, 2.2.2. All right, so Cloud Pickle is next. Cloud Pickle is 1.6.0 equals 1.6.0. Pandas, what is pandas? Pandas. Where are you at, pandas? Pandas, where you at? Okay, 1.3.1. And so I guess the one good thing that I did do before this project started is I tried to upload or update all of my local dependencies or like my master dependencies to like the latest versions. So I'm pretty sure these are all the latest versions of these Python libraries. Which, by the way, if you want to do a quick check to see what those like the latest versions of things are, so you might recall that we are doing. Sorry, Dad. Uh, just had to decline his FaceTime call. Sorry about that, Dad. All right, so all right, what were we doing? Got a little bit distracted. Oh, PyPy. So we are installing these dependencies from PyPy. So if you want to check what the latest version of something is, the easiest thing to do in my mind is go in here and search for something like pandas, and then it's usually like the first one. And then you can see the release history off on the left, and you can see all of these different things. So you can actually see September 12th, 2021, which was just a couple days, like a week ago, that 1.3.3 was released. And what was I using? So I think I'm still on 1.3.2. Oh wow, no, I'm on 1.3.1. I'm not going to update that just because, I don't want to mess anything up. But, I with minor versions like this, usually the risk of breaking something is pretty low, but you still don't want to go messing with something that unless you retrain the model as a whole. Yeah, which again, so this is another important topic. Sorry, all over the place again. Sorry, folks. The reason that it is important to okay, I'm jumbling my thoughts. All right, so we in the data science community as a whole are getting very interested in this thing called MLOps. MLOps, in case you are curious, if you've heard of DevOps. So let's talk about DevOps. So DevOps is this concept where you create your code on your machine or wherever, and then you have this pipeline that is constantly deploying that code out to an environment or out. Well, and when I mean constantly, I mean like you can set it to be automatic, but you don't have. It doesn't have to be automatic. But anyways, it's just this idea that you are constantly integrating your code out into production, and so and the way we do that is through some sort of continuous integration, continuous delivery pipeline, CI/CD pipeline. You could use something like GitLab, Jenkins, things like that. So with MLOps is this idea where we want to automate the full process of a model training to a model deployment. And the reason that's important is because, let's say one of these packages needs to be updated for some new security vulnerability. Well, if you update your model deployment like if it's an API or something, and then you try to import the pickle file that you created the model with, there's a potential that pickle file might not load or it might not work. And that's because it's using an older version of these dependencies. And so that's why MLOps is important, is because then you can easily do a model retrain. And then with that model retrain, you can serialize that file with the newer versions of these libraries in a way that you can't really do if you don't have a model retrain mechanism. And so that's why that's one of the reasons MLOps is becoming super important. All right, so back to here. All right, so let me get the dependencies for Fast API and Unicorn. Fast API, where are you at? Fast API, I think, where are you? Fast API 0.6.8 or 0.68.0. Okay, and then Unicorn. Where are you? All right, 0.15.0. 0.15.0. Okay, so that is done. All right, so next thing that we have to do is, in order to make use of this requirements.txt file appropriately, we need to copy it over into the Docker image as it's being built, and then from there we can do a pip install using that requirements.txt file. So the way we do that is using this copy command. So we are going to copy from our dependencies/requirements.txt. And I don't remember exactly where you put it, or maybe you can just put it anywhere, requirements.txt, and because I don't think that necessarily matters. We'll see here in a second. So it's copying that over, and then we're going to use this other keyword command within a Docker file called run. And as part of this run command, we are going to run the pip install command. So pip install r, is it r? Requirements.txt. So I'm going off memory with all of this, folks. So I may have screwed some syntax and stuff up here, but that's okay. All right, so we run pip install requirements.txt. Then we are going to move the project files from local into the Docker image. So again, we're going to use the copy command here. Okay, sorry, I'm a little distracted just because I'm trying to remember the precise, the best way to do this. Okay, all right, so copy container into container, and then copy models into models, just like that. So this is very similar to like the regular cp command that you might see with like Linux. And then one other thing that I like to do is setting the working directory to be container. And so the reason I'm a little bit distracted is because I mentioned before already that we are going to use this Docker container later on for AWS SageMaker, and there are a couple of other things that I know that you have to set, or a couple of specific things. And actually, I'm going to go ahead and do it. So actually, it is. So we are copying the container into. They actually want us to copy it into opt/program. And with the models, this doesn't necessarily matter, but I'm going to copy it into opt/models. And then you have to set a couple of other environment variables as well. And so actually right before I booted up the live stream here, I knew I would forget this part for sure, but that's why I'm going and referencing this documentation that I've got here. So you can see they're using a standard Ubuntu image, and they are doing an apt-get, which is apt. What does that stand for? Something package something, where they're installing a couple of things that they'll need, and then they are also setting these environment variables. So this is how you set the environment variables, is with this env command. And so I remember that you do need these special environment variables in order for this thing to work here. So it's Python buffered equals true. Here, let me see if I can remember this. All right, setting. Well, let me go ahead and do this here, because I keep remembering things that I want to mention. Remembering things that I want to mention, I don't want to forget them. Setting the environment variables required by AWS SageMaker. And so if we were just doing this, building this container outright and weren't so concerned about AWS SageMaker, I don't know if I'd bother with these environment variables. So n, I think it was called Python buffered equals true. Is that correct? Let me go back and look. Okay, so Python buffered equals true. That is correct. Python don't write bytecode equals true. And Python don't write bytecode equals true. And then finally, we're going to do another. I think it was like the path. We had to set the path variable. And so I'm not going to worry about explaining some of these concepts to you. Just note that the reason that we're doing this here is because we need it for AWS SageMaker, which we will not cover today, but we'll cover in a future live stream. So opt program, and then we're going to set it to the path variable, $, brackets, path. Okay, so I think that's all we needed to set there. All right. And then so one other thing is, once you copy these things into the file, whenever you initialize the container, it will initialize into whatever default working directory it is. However, you can set it to be whatever you want. So I said originally we were going to do working directory to be that, but it's actually going to be an opt program. All right, so opt.program, and then we are going to call this workdir. So that is the keyword that we have to be mindful of here. And then I'm going to close this. Is there a way to close this? Okay. So workdir is going to be opt/program. Okay. And then I'm not going to do anything else here, but what a lot of people like to do is you can set like a default command that runs whenever like the Docker image is started. And I never understand what the difference between the two is, because sometimes, I'm remembering something else now. I do need to set or expose the port properly. So exposing the proper port. So we need to expose port 8080 because that is where our API is going to be served out of. Anyway, as I was saying here, this entry point, it can be the commands that you want set as default whenever the Docker image is started. So maybe you want to automatically start our Python image. So you can say, well, it's actually going to be or not our Python image. I meant to say API. So it would be this start API as such, and so I would need to copy this in here. And then entry point's a little bit weird because you actually have to you have these things like separated out as their own quotes as such, like I'm doing here. So like I would have to separate that, and I'm forgetting a comma here, and then I would have to do the same thing for these other things. So another comma, another quote. Oh my gosh, I accidentally locked my screen. Sorry about that. They put, as I've said before, so this is the Apple keyboard that I use. All right, this is the delete key right here. This is the lock key. Look how close they are. That's my only complaint about this keyboard. Otherwise, it's great. All right, so, and I'm going to put another quote here, and then API to API, and then I actually don't want to reload on this one because reload is really just for development usage. Okay, so this would be what the container would start with if I had set it that way, but we actually don't want to set that because SageMaker does some weird stuff with this, and I'll talk about that at another time. All right, so this is basically our Docker file, and I think it's all right. Like I said, I'm doing this all from memory, so I'm not sure if this is 100% right, so let's go ahead and run the appropriate Docker commands in order to build this image. Okay. So let me go ahead and clear this terminal down here. So, and this might be a bit tiny, so let me go ahead and do this as its own like terminal. That way I can make it as big as I want. All right, so let's go into repos, cd into Titanic SageMaker BYOC, and then, all right, so you can see that all of our things in there. So Docker file is right in the beginning there. All right, so let me make this a little bit bigger for y'all. Okay, so in order to build our Docker image, we are going to do a Docker build, and then the T. The T stands for tag. So if you want to, this is how we name our images. So I'm going to call this Titanic SageMaker BYOC. And because this is a development version, development versions of images are usually tagged with dev as such. All right, so Docker build, Titanic dev, and then the only other thing that we need to provide is what we call the build context, and the build context is just going to be this directory. So we're just going to do period. Now let's say if I did have my Docker file on another directory, or if I had it named something weird, then I can use this .f command, like flag command. So let's say I had my Docker file in the dependencies directory, which actually wouldn't be a bad idea now that I think about it, because I really don't like that Docker file just floating out there like that. But anyway, I digress. All right, so it would be dependencies / Docker file. But like I said, it is in our root directory here. So the only thing that we are going to pass in is the period. Okay, so this is what I wanted to mention. So the first thing that it'll do, it will download the image from Docker Hub. So you can see that it is what it's doing. So you can see right next to the from there, it is 1 out of 6 completed. And so that is the number of steps that it needs to complete. What Docker does that's super nice is that it caches your steps along the way. And so while this is continuing to build, let me show with the Docker file here. So the first thing it's going to do, obviously, is it's going to instantiate the base image. And then it's going to copy over this thing, and then it's going to run our pip command, and then going to set these environment variables, expose the port, and then copy these other things. So, the reason I call this the nice thing is because, and in fact, I'm going to move this up here from there to there, although it's already running, but it doesn't really matter. So let's say I just made one minor update to something in this container directory. Because all these steps up here that have come before are not changing, Docker knows to just use a cache. That way you can do basically an instantaneous build and then have these things like run really, really quickly. So that's why you need to be cognizant of the order in which you define these things in. So like setting the environment variable is not a big deal because that's a split second kind of thing to do. But like the actual pip install, might be one of the very I guess it could be one of the last things you do or the first thing you do. It's just a matter of like understanding like what things are going to be editing the most. And in this case, I'm probably going to be editing the files of the container directory the most, and that's why I set it to be like one of the last things that run. All right, so you can see here, in the very first time you do a build like this, it usually takes like 2 or 3 minutes, and that's why I kind of like, have let it go and have stopped it. So you can see here, it is on step 3 out of 6. So step number 1 was obviously just downloading that base image. Step number 2 is going to be running the pip install here, and so you can see that it is trying to download all these things and run them appropriately. I am a little bit concerned that this is running so long, which means that something didn't go right. So I'll just, this is not the first time I've created a Docker file. It's just the first time I've done it from memory like this. But usually this goes a little bit faster. So then the next step, obviously, after this would be setting the environment variables and exposing the port, and then copying the things over into the appropriate directories as such. So let's see if this continues to run. I'm actually going to check one of my other Docker files just to make sure that I didn't really screw something up. So, and this is a good time to refresh you on my own GitHub page. If you would like to follow along for this project, github.com/dkhundley, which is my name. What time is it? Just doing a time check. 5:05. Okay, we're doing okay. All right, and so within the repositories, we are working out of the Titanic SageMaker BYOC project. I still need to update the README. I apologize for that. And so, but this directory or this project contains everything that we've been doing here. So you might recall the first couple of streams we did all the fun stuff within these Jupyter notebooks, and then now we have like our container directory up here, and yeah. So what I like to do is I have a DS Quick Tips repository that has like all these different things representing the different projects I've worked on in the past. So I know that there's a clean Docker file working here just fine. Okay, so apparently I did use a Slim Buster here. So you can see here I am installing my dependencies as such, running the pip, copying things over, although I don't think that syntax is right there. Setting the working directory, or maybe my syntax is wrong. Maybe the slash does come first. We shall see. I was not using this image on SageMaker, which is why you don't see like the SageMaker specific stuff or like those special environment variables. All right, but I do know this image works because I tested it not too long ago. So let's check to see how things are going. So it looks like things like progressed a tiny bit. I don't know why stats models is taking so long to build. 219 seconds. That's not really common. Okay, so let us, as it noted, I think I do have these kind of backwards. So I think, or maybe I'm right, or maybe I was right the first time. I don't know. But I'm going to go ahead and change it because I'm pretty sure that the other one worked fine like this. So apologies. All right, so let's go ahead and fix those things. And these things aren't going to fix on the fly, though. Like, even though it's only on step 3 out of 6 here, it's still going to continue running just fine. So I am actually going to change this from the Python 3.8 to the Slim Buster. The only thing you need to know about the Slim Buster is just like it's a smaller version of the Python 3.8. It doesn't contain all the bells and whistles that we might not need. All right, so that's the only change I'm going to make. I think I did just have this as slash, which is fine. What did I have else in my Docker file here? Okay, so container pip installer r requirements.txt. Okay, so that's fine. And yeah. Okay, so I'm actually going to interrupt this build just because like something's wrong, and I don't know if it's because I'm using a different base image or what. So if I want to stop it, I can just do a Command C. All right, so I am going to run the exact same Docker build command, but because the first couple have already oh wait, no. I was going to say because the first couple have already run that, you'd see how the first couple steps would go really quick because of the caching. But I changed the base image, so actually it's going to change everything. So sorry about that. All right, so again, it's going to download the base image. So that should be done here in a second. So you can see that one moved a little bit quicker. So I don't know if our pip install is going to do anything better here. It seemed to struggle on scikit-learn. But it seems to be moving faster this time. And I'm trying to fill dead air with just me speaking because I don't like dead air. But usually it would just be me just sitting here just watching this thing like praying that nothing blows up, which is kind of what I'm doing now, except out loud. That way there's no dead air. Okay, so let's see if this is going to work for us. Do. All right. Still running. I wonder if I have any other images to show you while this one's still going. Um, okay, so actually, I'm going to open a new tab. What did that do? I don't know what I just did there. I don't know what Command R does, but it apparently didn't do anything. All right, so let me make this bigger for you all again. Why is it making it like the whole window bigger? I don't remember. Yeah, I just want to make the text bigger, not the window bigger, which is odd. Okay, now I made that really big. Hope you all can see just fine. I'm going to check to see if anybody's even watching. Okay, according to YouTube, nobody's watching, so I feel a little bit better about that. But if you're watching on the what do you call it, the restream, I apologize that I'm kind of dumb. Okay, so command error it out. So what errored out? Stats models errored out. Why did stats models error out? Well, what do I have for my fast API over here? Maybe I didn't have. All right, so under dependencies, requirement.txt 24.1. What version am I trying to install then? 24.1, 24.2. Okay, so no problem there. I wonder if it has to do with Cloud Pickle then. I don't know. Let me check. So, man, I really hope this doesn't not work. Okay, so we're gonna pull an audible here, and I'm going to show you a different image that I've built before that I'm pretty sure will work. So, Docker, and I just want to check to see here really quick. Docker run irisapi.dev. Okay, are you gonna run? That did not run. That didn't do anything. What? Docker ps. Okay, but it started. I wonder why it started in the background like that. That's interesting. Docker stop container. All right, so that stopped that. Okay. So let me go ahead and open one of my older projects just to show you. Like, in fact, I'm going to do this DS Quick Tips one. This window. Okay, so here. Oh, did I change things to Python 3.9 apparently? Maybe I did. Okay, so you can see in here, this is a different version of a project that I worked on before that I know did work just fine, so I hope it's going to continue working just fine here. My computer's being a little bit goofy right now. I don't know if you could see that. Like it did a zoom in, but it's not zooming in. So wow, this live stream is not going my way today, all. So all right, so I have my Docker file here. All right, so I should be able to go in here and then Docker. I don't know. I'm so confused why it did. Oh, I know why. It is because I have this D flag in here. So let me take out the D flag. But was it Iris API? Is that what I had called it? API? I don't remember how I built this Docker image, which is why I like to use shell scripts for stuff, folks, because I don't remember how I built this image. I don't remember if this particular image that I just loaded up is even connected to this repository. So, all right, but you can see here. Well, let's try this out. So I'm going to open up I'm going to split this over here. So the container should be running. And if this is the right directory, then I should be able to ping it just fine. All right, so cd curl scripts. All right, so s dash test predict, and okay, so apparently I did get this right. All right, so let me backtrack a little again. So I apologize again, folks, that I'm a little bit screwy right now, but something is wrong with my other Docker file, and I don't want to have to debug it here. All right, so Docker kind of runs in its own environment, and what I mean by that is, so we expose our API out. Here we're exposing it out on port 5001 and on this host here. When we actually run it within Docker, it will be exposed on port 5001, but within the environment that is Docker itself, which means that if I were to run, in fact, let me go ahead and show that. So I'm going to do a Docker run command, Docker run. So this image name is called Iris API, irisapi.dev. API dev, so it should start up just fine. All right, so you can see in here it says it has been started up on port 5001. So let's go ahead and do a bash predict in here. So let me go ahead and cat out or move my face first. Move my face up here. All right, so let me go ahead and do a cat on this just to show you what it's doing. So cat test predict, predict.sh. All right, so you can see it is just running a simple curl command against this predict endpoint. So let's see what happens when I try to predict. Cannot connect. Connection refused. Why is this connection refused? It started up over here. And this is what I'm talking about. By default, Docker does not expose these things to the outside world. So let me go ahead and shut this guy down. All right, so in order to expose ports to the outside world, we need to use Docker run the P flag. So the P flag is going to say, I have port, oh man, I can't remember what it is. I know, so these represents the port on the inside of the Docker container, and one represents the port on the outside of the world. And the reason I don't remember is because like most people just keep those the exact same, just so like you don't get confused. That's why they're both 5001 there. And then we know our image, and then when we run this, and then it will get started up, and this port is actually exposed to the outside world. And so when we run this bash test predict command, it will actually talk with this Docker container. So that's why these Docker containers are super nice, is we have taken just this little bit of code, and just to show you that this is just a little bit of code for the same API, let me show you the API. So within the container here, I have the API.py file. So this is a very, very simple API. In fact, it looks almost exactly the same as our Titanic one. So I'll debug that later to figure out why my Docker file wasn't working, and I will upload that to GitHub, of course. But yeah, so it is the only thing within this Docker container. And actually, let me see. I'm trying to remember if I can remember the commands to actually just look at the innards of a Docker container. So Docker, I think it's Docker run IT, and I think IT stands for, I don't remember what it stands for, but it basically allows your local terminal to interact with the innards of a Docker container. So I think it's Docker run IT iris or API dev, and then I think I'm going to do a bash. All right, let's see if this worked. No, that did not work. But that's because I wanted to override that command. I don't remember how to override that command. So I thought it was Docker run IT, or maybe it's Docker IT run. Docker IT run iris API dev bash. Yeah, I can't remember how to do it. Oh, that's embarrassing. A little bit. Well, I don't really do that on a regular basis, honestly. So let me see. Docker exec into or start bash into container. Okay, so just showing you. Okay, so I was right about the IT flag. All right, so Docker exec, is that really it? Show me an example, guys. Oh, well, so exec run will exec you into an already started container, but we actually just want to start it on the initialization of the container. Docker exec, I want to run versus exec. All right, so run IT, and then what if I want to override the entry point? Override entry point. Okay. So that's the one nice thing about knowing like these Docker things is at least you know what to Google, and honestly, knowing what to Google is half the battle. Okay, so Docker run override. So I have this, and he wants to run this. I always just jump down here to the first answer, and this looks like it might be a good one. Docker run. When you run Docker run command, Docker treats whatever is in that as a single shell file. Okay. If you have a bunch of arguments, this is okay. I'm a little bit confused. I'm going to switch to a different one. I know I kind of just jump all over the place because usually one of these things has something that just jumps out pretty well immediately, and that's what I try to use, is just whatever jumps out to me immediately. All right, so from Python 3.6 entry point, I want to override that entry point. I don't know what the command does. It must be any valid command. So this is what I was talking about, like where there's an entry point versus a command. Like they operate in very similar capacities, but there's something different about them. So that's why I'm not sure. I wonder if I can just so entry point. I wonder if this will work if I just define the entry point like that. So all right, Docker run IT. What was that? Entry point bin bash or bin.sh, and then an actual image. All right, so Docker run entry point. All right, so /bin/shell iris API dev Okay, and hopefully this will work. Wait, maybe it did. LS. All right, yes, it did work. All right, so I don't know if you can see this very well. I apologize, it's going to be a little bit tiny. So in the bottom left corner, I ran this. Um, this here is, but basically what we're looking at is the guts of the container right here. So if I did a pwd, is going to print our working directory, so we were in the container. I think CWD, yeah, CWD is not going to do anything for us. So if I go up one, so this is the guts of the container here. So this most of these things come from that base image that we defined. So in this case, it's going to be Python 3.9 Slimbuster. And so you can see that, there's our requirements.txt file that's been copied into there. And then we also copied our models in here. So you can see there's a models directory in here. And then we copied our container directory in here. So let's go cd into models just to show you that. So cd into models. And there's the iris model, which is this for this particular model. If it was if our other Docker files was working, you'd see our two pipeline files in there, or not two pipeline, two pickle files, one for the model, one for the pipeline. And then so cd into here and ls. All right, so cd back into container, and then there are all of our Python files here. So you can see, let me do a cat on api.py, and it'll be the exact same thing that you see above here. So yeah, and then if you want to exit out, then you can exit out. So, like I said, there's not really a reason why you want to get into the guts of the Docker file unless you are confused of why something's not working. And so actually, whenever I was first getting started with Docker, I kept having this issue where, here, let me just show you. Let me go back to our original project, Titanic SageMaker BYOC, this window. All right, so looking at the API file here, let me close this down, make this a little bit bigger, take a sip of my drink. Okay, so you can see where I am opening these things from like this very specific directory here. So it's going up one into models, RFC pipeline.pickle. And I was so silly about this, and I don't know why I didn't think about this properly, but I kept doing, here, let me show you the mistake that I made. I would copy things like this. So I would copy all the models into op program, copy all the files here into op container. And I wish this would build properly, but basically what this would do is we'd go into op program, and all the two pickle files would be in here as well, alongside all the other container files, which wouldn't work out well because this api.py file is looking to go up one into models directory and then looking for that file. Instead, the pickle file was just floating around there like freeform kind of. And I'm still confused why like this Docker build didn't work. So let me see if I can let's try one more time, just this Docker build command. So as you saw there, like the very first two commands like ran almost instantaneously because it is using the cache, because we had already tried running this once before. I'm still just, I'm going to have to research this later if this doesn't work again. Okay, so coming back into here, did I already update this? Okay, let's see if this works. And we'll find out here in a second because I think it actually failed out fairly quickly when it didn't work. Oh, and I think I'm using Python 3.8 here, so maybe I need to switch this to Python 3.9. Again, just speaking out loud here, feel like that's dead air. Anybody have any questions? Is anybody watching right now? Let me check my analytics. It appears nobody is watching right now. Totally fine. And all right, so this is still running. Let's see how this is going to go. All right, this is where I need like elevator music button. It seems to be running better so far. Failing to build stats models, which is okay, I think. Okay, there we go. It failed out again. Well, shoot. Oh, that's because I don't have GCC installed, probably. Oh, I wonder if that is the reason. Let me go back to my Docker file here, to my old Docker file, to see if I had done something. Because sometimes you need to install some other things that aren't may or may not be there. So maybe that was my mistake, is I didn't have those apt-get dependencies. So let me check my Docker file here. Although that seemed to be okay. But it also looks like I didn't push up the latest things from this.